I actually have this labeled as a lesson for Conics prerequisites. So yes, these are good skills, but the main reason I'm doing it for my class is because these are needed for what we're doing with conics, that is circles, ellipses, hyperbolas, and parabolas. So this will be a very brief review of finding the midpoint and of the distance formula. So for the midpoint, this is the midpoint formula. If you're trying to find for the point x1, y1 and x2, y2, their midpoint, you do it by adding the two x values together, x1 plus x2 over 2, and the y values together, y1 plus y2 over 2. So if you look at it, you're essentially just finding the average of the two. You're finding the average of the two x's, you're adding them together, dividing by 2. Same thing with the y's, and then you'll have your midpoint. So just one example here. We have x1 and y1, x2 and y2. So I'll add the two x's together and divide by 2. Add the two y's together and divide by 2. Negative 2 plus 6 is 4 over 2. 4 plus 5 is 9 over 2. So you could write your answer as either 2 and 9 halves, or if you prefer the decimal, you could do 2 and 4.5. Now, just in case you're wondering, it actually does not matter which x you put first or second and which y you put first or second. All it really matters is that you put the x's together in the first part and the y's together in the second part. Because since we're adding, it doesn't matter which one you pull from first. There are also times we'll have to use the distance formula. So if we're trying to find the distance between x1 and y1 and x2 and y2, we'll use this distance formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. If I have time, at the end of this video I'll show you where that comes from, because you may or may not have ever been told before where in the world they got the distance formula from. So here we go. Find the distance between these two. So here I have x1 and y1 and x2 and y2. Notice here we are subtracting, so the order really does, well actually no, because then we square it so it doesn't. So actually again, the order doesn't matter as long as you keep the x's together and the y's together. So with both midpoint and the distance formula, it actually doesn't really matter which x you pull from first or which y you pull from first, as long as you keep the x's together and the y's together. Just to be clear, the only reason it doesn't matter, even though we're subtracting, is because of this squared. Because once we square it, it doesn't matter whether we got a positive or a negative answer, we end up with the same result. But I'll stick with what we have written up there, just to keep it straight. So they say x2 minus x1 squared plus y2 minus y1 squared. So we have 2 plus 3, which is 5, being squared, negative 5 minus 7, which is negative 12 squared. That gives us, I should actually put this in parentheses. Make sure in your calculator you do the same, because this should end up a positive number. We get 25 plus 144 gives us the square root of 169, which is 13. For those of you taking my class, if it doesn't come out even, please leave it in radical form. We want to be more accurate by leaving it in radical form. So for something like square root of 51, that doesn't have an even root, so just leave it as the square root of 51. Don't do the decimal, leave it as the square root form. But this one was nice, ended up an even 13. Now that's all you have to know, but I want to very briefly show you where in the world this distance formula came from. So consider this part free. You don't have to remember it. Let's say we have a point up here, x1, y1, and a point down here, x2 and y2. We want to know the distance between those two. Well, the great mathematicians of old realized you could actually form a right triangle from this. Because up here we have x1, and this would be where x2 is located. So this distance right here could be called x2 minus x1. And then this up here is even with y1, and this down here is even with y2. So this distance could be labeled y2 minus y1. And since it's a right triangle, we know we could do the Pythagorean theorem. So let me make some room here so you can see how they came out to get this. We know the Pythagorean theorem is a squared plus b squared equals c squared. Only we're going to replace the a with x2 minus x1. And then b squared was the same as y2 minus y1. And then c is really the distance we're looking for. So then you can see, oh, sorry about the squared, that's important, equals c squared. So then all we need to do to solve for the distance is take the square root of both sides. Sorry about that. Take the square root of both sides and you end up with the distance formula. So believe it or not, the distance formula actually comes from the Pythagorean theorem. Hope you enjoyed that explanation. Have a wonderful day.